All right, looking at some ratios now. We're using some tape diagrams. First thing, kind of what do you notice? What do you wonder? Well, first thing I notice here is that this second one, the full length of this second one, is actually the same length as the original one. So this is equal to 1 up above. They both seem to increase by the same amount. Let's just see if I can. Just to see. If I were to take this and double it, how many would? Okay, I might not be able to get them perfect, but let's see. It does look like 3 make up the green here, and then I'm guessing 4 is going to make up the orange length. Yeah, there's a little gap, but if those gaps are gone, so then looks like this one is about 3/4 of the original, and this one is a 2/4 or 1/2 more than the bottom one. Nope, that's not right. Yeah, 2/4. Yeah, so half of the whole bottom one. Okay, so those are the things that I noticed. What are the dimensions? We know this is 1. So you can measure and find out what the dimension of the other one is compared to that. But just getting used to looking at, okay, what is something that we increased by a certain amount looks like in a tape diagram. Okay, so next, kind of thinking about those tape diagrams, how it might look for these situations. It says complete the table to show the total distance walked in each case. So Judah's pet turtle walked 10 feet and then half that length again. So walk 10 feet, then half of 10, which would be 5. So that's total distance would be 15 there. Okay, Jada's baby brother walked 3 yards and then half that length again. So 3 and then half would be 1.5. So altogether that'd be 4.5. Jada's hamster walked 4.5 kilometers and then half that distance again. So 4.5 plus half of that would be 2.25. So that would be 6.75. Jada's robot walked 1 mile and then half that again. Half of 1 is 0.5. So altogether that'd be 1.5. So remember, once again, with proportional relationships, whenever your x is 1, your y is the constant of proportionality. So x is going to equal, or y is going to equal 1.5 times x. Okay, so explain how you computed the total distance. There was 1.5 times x being the initial distance. Okay, it says 2 students each write down the equation to represent the relationship between the initial distance walked x and then the total distance walked y. Maya wrote y equals x plus 1/2 x. Kieran wrote y equals 3/2 of x. Well, 3/2 of x is equal to 1.5 x. So that is 1.5 x. So that checks out. But so does Maya. So you can also add, taking a whole amount and then half of that same amount is also going to give you 1.5. So if you were to use the distributive property here and pull out the x, you'd have 1n plus 1/2 times x. Well, order of operations, if you did it, what is in parentheses first, you get 1 and 1/2, which is 1.5 times x. So both of them are correct. So that answers that one. Do you agree with either of them? Explain your reasoning. So yes, they're both correct. It's the same equation, just written a little different. Okay, it says, are you ready for more here? Zeno jumps 8 meters, then he jumps half as far again. Then he jumps half as far again. So after 3 jumps, he was 8 plus 4 plus 2, which equals 14 meters from his starting place. Then it says Zeno kept jumping half as far again. Would he be after 4 jumps, 5 jumps, 6 jumps? So at 3 jumps, he's at 14. And last he jumped 2, so half of that is 1. So that equals 15. So that would be 4. So then at 5 jumps, half of 1, which is, so he's at 15 plus 0.5. That's going to equal 15.5. Okay, the 6th jump, it's now going to be half of 0.5. And we know he's at 15.5 as it is. Half of 0.5 is 0.25. So that's going to equal 15.75. Okay, so it says before he starts jumping, Zeno put a mark on the floor that was exactly 16 meters from his starting place. How close can Zeno get to the mark if he keeps jumping half as far again? So each time he keeps getting half the distance he needs to go. But the thing is with that, he'll get very close to it, but he'll never actually get right up to the mark. So you can work it out, but if you want, you can do this. Consider researching Zeno's paradox. But he keeps getting half the distance, which gets infinitely smaller and smaller and smaller, and never reaching 16. Okay. The last part we're going to look at here is, can you line up tape diagrams with statements? So the statements that it's going to refer to are going to be over here. Okay. Han ate X ounces of blueberries. Maya ate a third less than that. So where's one that shows 3, right? If ate a third less, this original X is broken into thirds. And so Y is 2/3, which would be 1/3 less than 3/3. So A would go with C. Maya bikes X miles. Han bikes 2/3 more than that. So now that would be, that one would go with B here. Okay, because the original, they biked 3/3, and then Han did 2/3 more than that original one. So hence the 2/3 more. Okay, Han bought X pounds of apples. Maya bought 2/3 of that. So once again, C would go with C as well, because about 2/3 of the original is this Y right here, right? It encompasses those 2 out of the 3 altogether, so that's 2/3. Okay, so that's just looking at tape diagrams and connecting them with each one. Okay, next it says for each diagram, write an equation that represents the relationship between X and Y. So diagram A, this one could be Hans ran 1 mile. Maya ran a third mile more. Okay, for B, let's see, you could say Maya 8 1 pack of blueberries, on 8 3/5 of a pack. And so on. Diagram C. So right there you could put Han ran for an hour. Maya ran for 40 minutes. And the last one, so using the same, see, Maya worked for 3 hours, Han worked for 1. They all could represent those diagrams there. It says write a story for one of the diagrams that doesn't have a match. Oops. So I didn't do this right. So let's see, the one that didn't match any, we'll stick with this first one. So I didn't read the question right. I'm supposed to write the equation, not a story for each one. So the equation being in y equals k times x, or something along that line. So y equals three-fourths x. Nope, I did that backwards. Y equals 4/3 of x. Right, because if you times x by 4/3, you get the 3/3 plus the 1/3 to give you the length of y. Diagram B, so y equals 5/3 x. And so you'll notice the constant of proportionality, or my multiple, is just the number of sections that make up y. Right, so the next one, y equals 2/3 of x. And the last one, y equals 1/3 x. So when y was bigger, then we're multiplying by a number greater than 1. When y was smaller, we're multiplying by a fraction that is less than 1. All right, 4.4 we're not going to worry about. But here this just goes over how we use tape diagrams and write stories dealing with those.